Here we're going to try to show the super radiance of a Krypton bulb powered by alternator resonant circuits. And I'll have to get up there close to read that. I don't know how the film will come out. Quantum optics. For want of a better term, a gas which is radiating strongly because of coherence will be called superradiant. Robert H. Dickey, 1954. If the wavelength of the light is much greater than the separation of the emitters, then the emitters interact with the light in a collective and coherent fashion. Thus the yellow underlined portions I'm reading. The effect has recently been used to produce a super radiant laser. So what we're going to try to do here is show the three levels of the Krypton bulb discharge and how in fact it resembles this super radiance. And then to show that, we like to have a pair of power measurements going on. And so then this whole device then try to show this repeatedly. Any problems with the camera stretches and all that? No hum. What we got there, you see a motor there, turning a three-phase car alternator, and those three alligator clip wires. We need to make an improvement there. The only thing powering the whole thing from the three-phase, and we also have a high-tech stuff called a regulated power supply. It's very costly, and that's what we use to put energy into the field so that it's ripple free. And on that field we have recently marked down on the wood three levels of operation, which don't know if the camera can see it, but it's 8 volts, 11.3 volts, and 21.8 volts. The 21.8 volts will see the super radiance of the Krypton bulb discharge, and note now what's going on with that. In a previous video I showed how the Krypton bulb will resemble a arc in a Tesla arc gap. I don't think this will actually happen with ferromagnetic transformers, and we're going to see why here in a second. In front of that bulb is a broken xenon bulb. The xenon bulbs employ the same principle as the Krypton bulbs, but I only have this Krypton bulb here to show for the demonstrations. Okay then, so we want to turn it on and show the relative voltages and amperages on the system. Then we want to turn the field on to an 8 volt open circuit voltage. And then we can note the xenon discharge and secondary effects involved there. Oh wow, I guess we already had the field engaged. That's okay, make the video shorter. From the 8 volt open circuit, it's hard to believe what these things do on their imbalance, but it would appear that 8 volt circuit, sometimes the circuits want to send energy back against themselves in the 3 volt relationship, and that's rated about 8.1 volts. 8.2 volts. According to the testing, we get an 8 volt open circuit. We got 7.1 volts there, 7.1 on phase 3. On our amperages, we have to adjust that. diagnosis. But let's assume it's working. Fortunately, it means we're going to have to duplicate everything. Now we're going to put the garage door down and look at the secondary thing. There's the xenon discharge at that level. When we go back and we look. There's the neons attached to the plates from each of the top two secondaries. And we really need to see all three discharges in one shot. So we're going to try to get the camera around here. And for simplicity, we're just going to proceed from here up to the radiant discharge. We need to have all three bulbs on the screen. It's hard to tell in here. I'm going to have to take out some lighting. I have to walk across the room. That should probably give us a better indication. We do need to show both the top and bottom discharges at the same time as the Krypton discharge. Trying to get that in there. I think that's going to work then. We're going to go up 2 levels. We're at an 8-volt open operating circuit. We just went up to the second graduation, and our meters are reading a little over, but that's not what we're about here. We want to go right up there. Our meters are reading on phase 1. .5, 10.4, and 10.4 on 2 and 3. Now, I don't know if we can denote any shrink in the discharge. We got all 3 bulbs. We're going to go up to the highest level now of 21.8 volts open circuit. Okay, that's not what I'm accustomed to seeing at all. And when I've done this kind of thing in the past, xenon bulbs taking a very laser-like quality, and it's not doing that now. And so we're going to have to call this quits. Before we do that, we want to look at our input voltages. We'll turn the light on to see that. Which is quite remarkable. We can find out where we're at. There we are, coming through. I've seen this effect before at this level. So it's good to be able to. Oh, it's document this damn thing. Where was I at? There we are. Okay, we're about ready to finish here. Like that, about ready to finish here. I think we need to put the garage door up. We'll take one more thing of this thing. Now the bulbs appear to be blinking rapidly. Top and bottom. And there's the Krypton bulb doing its thing. Which is a little different from what it normally did. We're going to open the door up. Like I say, you see that broken bulb there. It's arcing through the glass right there in behind the electrode. So I don't know how long these kind of bulbs would last. We want to see what our power input is. And on this one here then, phase 1 has gone up to 27.4 volts, 21.3, 21.3, and I have already measured it's a 21.8 volt open circuit. So it's going above, it's exhibiting some kind of negative resistance. The net discharge, which is not what I wanted to film, but it's done anyway. Thank you, everybody.